Hello everyone. Today we start the first chapter of differential equation, which is introduction and preliminaries. In the previous video, I discussed the content of this chapter. So let us start the chapter 1. So in this chapter, the first concept is variable. So first of all, you need to know what is variable. Variable means unknowns. It means we don't know what is the exact value of that. Okay, so the variable, if we define it, what is variable? So the symbol which are used for writing algebraic expressions are known as variables or unknowns. For examples, x, y, z, and so on. These are variables because we don't know what is the exact value of x, what is the exact value of y. Okay, so now we go for type of variables. There are two types of variable. First one, independent variable, and second is dependent variable. So what is independent variable and what is dependent variable? I will make you understand. So if we go for independent variable, the variable to which value are assigned is known as the independent variable. And what is dependent variable? The variable whose value is obtained corresponding to the assigned value is called the dependent variable. I will give one example that will clear to you what is independent variable and what is dependent variable. Suppose we have a function y equal to x square. So here we have two variables. First one x and second is y. So in this equation, in this function, what is independent variable and what is dependent variable? So here we see that if we give the value of x, then we get the value of y. Suppose let us take the value of x is 1. So we get the value of y, which is 1. It means here the value of y is dependent on the value of x. So we can say that this variable y is dependent variable and this variable x is independent variable. Is it clear now? Okay, so in general form, the example of independent and dependent variable are if we have a function from a to b, then each assigned value x belongs to a, there exists a unique y belongs to b such that y equal to fx. It means here x is independent variable and y is dependent variable. Let us take one more example like that we have y equal to minus h. So here if we put the value of x is 2, then we get the value of y. It means the value of y is dependent on x. So now it's clear what is independent variable and what is dependent variable. Okay. So now we go for next. And now we go for the concept of derivatives. So first of all, what do you mean? What is derivative? So the derivatives, the concept of derivative is at the core of calculus and modern mathematics. There are two ways to define derivative. First one, the physical concept of derivative. Second is geometrical concept of derivative. So in the physical concept of derivative, so the physical concept of derivative is given by Newton in development of classical mechanics. The rate of change of variable with respect to another variable is called derivative. If we talk about velocity, then do you know what is velocity? Velocity is a rate of change of distance with respect to time. So here we have two variables. First one is uh, distance and second is time. So here the rate of change of distance with respect to time is velocity. It means this is the derivative also. So now is it clear how we can define derivative by using physical concept? So we can write it ds by dt. It means the derivative of s with respect to t. Is it clear? Okay, so now we go for the geometrical concept of derivatives. Suppose, so let us consider the function y equal to fx and its graph of one variable x and then derivatives of y at a point p is the slope of tangent to the curve y equal to fx at p and denoted by dy by dx and called total derivative. You can understand it like that. Suppose we have this. We have a function y equal to fx. Do you know if we draw a 2D curve, then which variable we take on x-axis and which variable we take on y-axis? So if you don't know, I will tell you about this. The variable which are on our hand, it means which will give the value. Then we take it as x direction. It means in the function y equal to fx. Here we give the value of x. It means we take independent variable on x-axis and we take dependent variable on y-axis. Okay, and when we draw the graph, suppose we have a function y equal to x. So the graph of y equal to x. So at any point, the slope of, suppose we have to find the slope at this point. And suppose this point is p action y. Do you know what is the means of this p action y? It means here this point p is x distance from x direction and y distance from y direction. Okay, so the slope of at this point p is known as the derivatives at that point. So, and it is denoted by dy by dx. Okay, and we call it the total derivative. So this concept is clear to you or not? Okay, sure. Thank you for watching this video.